Okay, good morning, everyone. How did your homework go? Any questions about the homework? Number 40. Okay, anything else? Anybody else? Okay, we look at number 40 then. Stop. So we have to find the limit as h goes to 0 of 1 over 5 plus h minus 1 over 5, the whole thing divided by h. All right, so of course, this when h goes to 0, the denominator goes to 0, so we definitely have an issue. So the denominator go to 0, we have an issue. And not even the denominator, if we go here in the numerator, when h becomes small, 5 plus h become close to 5. So 1 over that become close to 1 over 5, and minus 1 over 5 become close to 0. So we have two issues, not only the denominator, the numerator also go to 0. So we have a problem. So the way we do this to get rid of, to fix this, is basically take the numerator, this one, and find a common denominator just to make the fraction simpler. And then we hope that things will work out. So this becomes the limit as h goes to 0 of. The denominator is h, I don't have an issue with it. Now I need a common denominator here. Now the common denominator here, the common denominator is the product, 5 plus h times h. So we have to find this common denominator. So this will give me, if this is 5 plus h, the common denominator is 5 plus h times h. So I have to multiply both by h. Minus, I have a 5 in here. The common denominator 5 plus h. So I need to multiply both by 5 plus h right there. Okay. So now I created a common denominator, which means I can combine my numerator carefully. So this would give me the limit as h goes to 0. That's my h. My numerator become h minus parentheses. The parentheses are crucial. Over h times 5 plus h. Now we use two things. We use the property of fraction that divided by h is like multiplying by 1 over h. And now the numerator will become, and now let us do it here. This will give me h, distribute the minus, minus h. All right, so the rest is some simplification in order. So this will give me the limit. I feel I have a mistake. Oh no. Okay. I feel I have a mistake. What's my mistake? Oh, come on guys, you should tell me. I did a stupid mistake and the common denominator, I don't know where I brought my, so that should be 5, my apology. 5, I was wondering, what am I doing wrong? So this is 5. Okay, please, all of you correct. This is 5. And so this will give me 5. And this gives me 5. And this gives me, what else? 5. And this gives me 5. Okay, Please correct if you're writing. You should have corrected me. So this will give me equal to. So now I have the 5 minus the 5 cancel out. I will have the minus h over 5 times the 5 plus h times the 1 over h. Now my h simplified, leaving me with the expression, the limit as h goes to 0 of minus 1 over 5 times 5 plus h. End of the problem. Okay. Any questions beside number 40? Sorry for this stupid mistake here. Any other questions from the homework? All right. So today we're going to talk about section 1.4, which is section 2.5, limit at infinity. At infinity. I meant infinite limit, right? Yeah, it's infinite limit, sorry. And that's 2.4. Infinite limit. I have the wrong page on my book. Infinite limit. Okay, so let us see what this is about. I start with two very simple examples. Actually, something that I almost started yesterday. Let me take us, let's do the following. Let us compute the limit as x become close to 1, for example, of the following. I'm going to take a very simple expression. 4 over x minus 1, and I'm going to square it as well. All right. First, we analyze what's really happening here. The numerator is 4. It's the denominator. When x become close to 1, x minus 1 become close to 0. So the denominator is becoming close to 0. But the numerator is 4, is not 0. So what happened to the ratio now when x become close to 1? So when x become close to 1, the denominator is very small. So basically, I'm going to have 4 over something very, very small. And yesterday, we kind of looked at this very briefly, and we decided what will happen. So let me do it one more time and see it. So I'm going to just take x, and this is 4 over x minus 1 squared. This is x, and that's 4 over x minus 1 squared. And remember, we have to take larger values than 1 and smaller than 1. We have to take limit from both sides. Whenever there is limit, and let they tell me plus or minus, I have to take the limit from both sides. Okay, so let us take values close to 1 and see what will happen. So close to 1, so I can positive, so I can take 0.1. I will not take a lot. 1.01 and 1 point, let us say 0.001 once, and then we see what happens. So this will give me 4 over 1.1 minus 1, it means 0.1 square. Right, 4 over 0.1 square, it means 4 over 100. So 4 over, it means 4 over 1 over 100. So this should give me 400. So the problem is 400. Now here, I will get 0.01 square. So I'm dividing 4 now by a very tiny number. You know, 0.01, it means it is a tiny number. 0.01 square is even smaller. So if I really do the math, and if I'm not goofing, we should get something like 4,000, right? This is 10 to the minus 2, so something like that. Okay, now if we keep going, what should we get? Okay, 1.001, what will happen? So when I take this one, I will have 0.0001 square. So the number even, I'm dividing by something which is really small, the number is going to be even larger. I don't know how many zeros, lots of zeros. So what's going to happen here? When my x is becoming close to 1, because my denominator is becoming very small, so if I take a non-zero number, and that's crucial, non-zero number, divided by a very small number, I'm going to get something very large. And math, but how do we express this? We said when x is becoming close to 1, this is going to become close to infinity. The idea that is keep growing and growing and growing and growing. Now, if I take values less than 1, we will see that the picture will not change because I have a square in here. If I take 0.1, so I will have 0.1 squared, which is going to give me again a 400. So even if I take values close to 1, but less than 1, the denominator is still very small. And since we're squaring it, this is going to give me another large number. So as x becoming close to 1 here, f of x is taking larger and larger value. We say that x goes to plus infinity. Okay? So every time we take non-zero number, divide by a very tiny number, but you're going to get really a large number. And how will this affect graphically? This is 1. So now how does this affect the graph of the function 4 over x minus 1? At 1, the function doesn't make sense whatsoever. It's not defined, period. But when getting close to 1, from either side, my function is blowing up. It's going like this. So that's really how the effect on the function. At 1, the function is not defined, and from both sides going to infinity. And we're going to say that in this case, the line x equal to 1 is a vertical asymptote. Is a vertical asymptote. It means that the value of the function, when we're becoming close to 1, going to infinity. Okay, so let me take a small variation now on this problem and then the idea. Please, any questions as we move on? Let us say, instead of taking the limit as x tends to 1 of 4 over x minus 1 squared, I have a very small variation. I take the limit as x goes to 1 of 4 over x minus 1, okay, without the square. What do you think is going to be the effect of not squaring? So I took the same problem, I changed tiny bit, I removed the square. What do you think is going to be the effect?
It's going to go to infinity, but it's just going to be like a lot longer. It's going to take a lot more numbers to get to infinity. But
Repeat.
You won't, like, when you plug in the numbers, it'd go up, but it won't go up as fast as, so it'd be like 40 and then 400 and then 4,000.
That's a very good point. You're absolutely correct. But something else also is going to happen. You're correct. You're definitely correct. Yeah, it won't get as big as fast. That's fine. That's right. What else do you think is going to happen? Okay, so I will draw the picture. So what your classmate says is not going to go as fast. She's absolutely correct. But also something is going to happen. So I'm still going to take scenario bigger than 1. Exactly. Then, and the scenario less than 1. You know, I always have to take both scenarios. Okay, so now let us see. I will do the same, 1.1. So it's still, when x become close to 1, I'm taking, this is still very small, but what kind of small it is? It's small, but it's going to be positively small. So that's 400. 1.01. So 2 things happen. One's what your classmate said, 100% correct. It's not going to go to infinity very fast, but it will eventually go. 0.01, that's going to give me 4,000. However, when I start taking values less than 1, like 0.9, this is going to be 4 over. Now let us watch. If I put 0.9 here, minus 1, I'm going to have minus 0.1. Oh, sorry, this is 40. Which is going to give me minus 40. If I take 0.99, plug in 0.99 here, minus 1, this is going to give me a negative, a small negative. Not small, not only small, that's small negative. So 4 over minus 0.01, which is going to give me minus 400. Okay, the asymptote will be toward absolutely. We're going to have an asymptote, but the behavior of the function is going to change in both sides. Absolutely fine. So when x is becoming close to 1 in here, the output will still become large. You know, when I take 1.001, I have 4,000, and so on and so forth. However, from here, it's going to go to minus infinity. So two things. First, the limit in this case actually does not exist because it doesn't go to infinity. So two things happen. So there is no limit. I don't know what the limit is. If I tell you the limit is infinity, it means I am telling you the numbers are becoming very large, positively large. If I tell you negative infinity, it means I'm telling you they are becoming large, but negatively large. So in this scenario, two things are happening. So the limit for us does not actually exist. And here's the picture. X equal to 1. The function is not defined, there is no output. And according to my picture, when I'm taking values bigger than 1, my function is going like that, go to plus infinity. And when I'm taking less than 1, my function is actually doing this. My function is going to minus infinity. Okay, so in this case, the limit does not exist. However, what? We can talk about one-sided limit in this scenario. Please, if I'm going fast, stop me and let me know. Crucial to help me out. Okay. However, what can we say? Actually, let me take a new piece of paper here. However, what can we say? We can say the following, according to this. The limit. So we're going to talk now about one-sided limit like we did before. One-sided limit. The limit as x become close to 1 from the positive of 4 over x minus 1. So let us remember what this means. It means when x takes value close to 1, but larger than 1. X minus 1 is going to take very small values, but positive values. And that's crucial. So this is going to become very small, but positive. So anything, a non-zero number, you divide it by a very, very small number, this will be the plus infinity. And the limit, as x becoming close to 1 from the negative of 4 over x minus 1, it means that, well, I always analyze, it means x become close to 1, but less than 1. So in my mind, it's 0.9 minus 1, 0.99 minus 1. So this is fairly small, but negative. Okay? So I'm dividing 4 by minus 10 to the minus 1. 4 divided by minus 10 to the minus 2. So in my mind is minus 0.01. Minus 0.001. That's what I am dividing. And this is going to give me a negative number. So this is really what we call infinite limit. So when I say a function is going to plus infinity, it means I'm telling you that the function grows without bound. It keeps getting larger and larger. When I say the function going to minus infinity, means the function is taking larger and larger negative value and keep taking more and more negative value. Okay, so this section is actually relatively simple. So I take one example and then we go back to the quiz. So suppose I ask you find the limit as x goes to 16 and I want 16 from the negative of, let us say, minus x squared plus 4 over x minus 16. Okay, it looks complicated, but we're gonna study it verbatim. So what's gonna be the limit? All right. First, we see if we have a problem. If we don't, we don't. Okay, do we? When x become close to 16, the denominator will definitely become close to 0. So I already have an issue with the denominator. And let us see. The denominator become very small. And I'm always concerned. Is it small positive or negative? 16 from the negative, it means like 15.9, 15.99. Minus 16, very small negative. Very good. That's the denominator. Now I go up here. Is this becoming close to 0 or not? Okay, definitely not. When x becomes close to 16, so this will become minus 16 squared plus 4. And this will give me, okay, my calculator is next to me, minus 16 squared, okay, plus 4. This gives me minus 252. So the numerator is not 0. So I have a number, which is negative, divided by something very, very small and negative. So what is going to happen eventually when I keep taking values closer and closer to 16 from the negative? What's going to be the limit? I'm not having any answer. Plus infinity Elizabeth, positive infinity Davis, positive, absolutely correct. Because I will have, in your mind, that's what you have. Minus 252, which is a number, not 0, divided by small negative. So minus, that's what you put in your head, minus 0.01. Or minus 2.52 minus 0.00001. That's really what's the picture here. Those minuses definitely will cancel out. And when you have this divided by very tiny, you're going to get a positive infinity. Okay. So this section is actually not hard. I will, of course, assign problem. You just have to analyze very, very clearly every piece of the problem. Right, so with this, we stop today's, and I want you to go and get going with your quiz. All right, get started. You guys remember, I'm sure, how you do it. You go to content, quizzes, quiz 3, and get going. Did you all find it? Okay, no answer, it means you did. Okay, good luck. Sorry, everyone, to interrupt you, but exam 1 is next Friday, and I will be sending you the review over the weekend.
On 2b, do you mean that it's -4 as x goes to -4 or just 4?
I think it's just 4, man.
All right.
I have a question. For 2C, it says -4 plus. Does that mean we just do -4 and +4?
These question on the chat only.